but we also do emission control and combustion efficiency, right? So a quick background.
Yes, clicking just slow.
Slow.
Yeah.
I think easier for you to control.
Okay. Yeah. We'll go to the second.
Yeah. All right. So if you read the, you go and read the news today, everybody is talking about energy transition, right? So I think why is that a big deal for the industry? So first, actually, for me, this is my own interpretation. So open dialogue, right? And the energy transition is not a new thing. And the journey of human civilization is perfect reflection of the energy transition from old days to now, industrial revolution. You can see there, right? And that's also part of the Panametrics history. Over the last 50, 60 years, as you can see, the mix of energy source is largely wood, coal, and oil, gas, nuclear, electricity, solar, right? So I think that's we ride on that history of that energy transition period. Right? It's not a new thing, but I think it offers unique risk and opportunity to the oil and gas industry. That's my own interpretation there. So historically, energy transition is largely driven by the depletion of one energy source. And but now, this round of energy transition is more driven by the global awareness of emissions and its environmental impact, right? So what does that mean? So it means many things in my view, but the two things I think that were critical for us to understand is that to the oil and gas industry. So it really means that there's regulators there. Feel free to chime in if you disagree, right? The way I see it is that it really means stricter regulations for sure. And it's not only the US, you travel across the globe and the stricter regulations come on emissions control. That's one thing. And really, it also means operation excellence. I talked to the Exxon locate last night. So I think it's a lot tougher for operators to operate those refineries or petrochemicals and with a good product. It's harder. That really requires that you have operational excellence, minimize the waste. So bear those two in mind. That's exactly what I think FlareIQ can offer. As I said, by training, by nature, I'm not a salesperson, but I try to go through what's in my mind from technology point of view. Next slide. Yeah. So if you go to the website and you search, those big buzzwords is all over the place. Climate flight, carbon footprint, and methane reduction. So on one hand, when we think about energy transition, we are thinking, hey, natural gas is going to play a bigger role moving forward. On the other hand, we also think methane, that's bad. Well, we realize it's bad for a long time. It's just never to this order of magnitude, right? So what does that mean? So next slide. So why are we saying a certain thing there, right? So I think that's really come down to the carbon footprint. And so I think the carbon footprint is really the total emissions and expressed as carbon dioxide or equivalent, right? The major carbon footprint source for us is carbon dioxide and methane. Methane is the major part of natural gas, basically, right? So when it comes to warming the planet, methane is much worse. So in other words, methane has a much more warming power compared to carbon dioxide. Carbon dioxide is bad by itself, but this is at a different level, methane. That's really important for us to understand. So it's 80 times more warming power compared to CO2 over a 20-year period, right? So then you think about where the greenhouse gas is coming from. Carbon dioxide is really 80%, and the methane is only 10%. But when you multiply by 80 times, or even 20 times, depending on the number of years you are looking at the farm, so methane is becoming a major problem. That's why you read the news, so methane is bad, bad, bad. And there's a reason for that. Where does methane come from? There's many different sources there of methane. So right, natural gas, oil and gas industry is 31%. That's the largest. Then you think about enteric fermentation. That's the cows, the farms, the cattle, right? So that's why you read the news or reduce the consumption of meat, right? That's also part of that. There's a landfill of other things there I'm not going to talk about. So oil and gas is focused here, right? So, so why we should care? There's a regulators be really care, government be really care. So I reference some regulation there. MAC rule, TCEQ, right? So different rules there. You can read it. So I think everything comes down to how is that related to a flare system. That's what we are going to talk about today. Right? So if you think about that, right? So I think a flare stack, for example, that's really the sewage system in the refinery or petrochemical system. That's really anything you don't want done to that. Then eventually it will be burned, right? Where do you see that? So refinery, petrochemical, offshore platform, wellhead, that's the upstream thing we talked about there. And keep going. Yeah, so I think chemical and also then the LNG. So I think last time we also talked to pipeline. I think Golden Pass. So that's the LNG facility there. So there's one common theme, and when it comes to those, landfill, that's another thing. They all produce methane. So they all produce one way or the other. So right, so I think going down further, you see when you produce methane, there's only a couple of things. It's if you think about methane as an equation, this is the schematic when you think about an oil gas plant. Whether it's petrochemical, offshore, and this is pretty much summarized like that. So you start with some kind of raw materials. For refinery, it's a crude oil. And then you go through different processing units, whether it's for jet fuel and for gasoline, diesel, different things there. Eventually, you have those smaller flare lateral lines combined to a main header. You go through, there's a like knockout drum, flashback seal, you go all the way to the top. That's you burn anything at the flare top, right? That's really schematic there. So the reason why I highlighted here is that you see that's where the methane comes from. So methane sources are from different processing units combined, and then you also have some kind of a purge gas. Could be nitrogen, and also could be a natural gas, methane there as well. I think there's also part of the plate. For flare top, you need to have a part of the plate. You need to supply the fuel gas to burn that. So all those are the sources there. So where those methane is going to go? A few things there. They can go and they can go basically leak. The valve is leaking, then that's where you're going to see some leak. And then also at the flare top, you are going to burn that. So if you can go down, so this is really how methane is balanced. The source minus the flare gas recovery system, if you have one. Not every facility has one. Then it will be burned. Then anything left will be the methane emissions. And so next one. If you think about the combustion, right? And it's really pretty straightforward. Methane is burned to become CO2 at H2O. As I mentioned earlier, this is bad enough by itself. If you are not burning that, it's much worse because of methane. If you are not burning that, basically it will go escape to the air, right? So suppose you have 50% of combustion efficiency, which really means you are going to have a 50% of methane go to the air directly, and then the other 50% will be burned. So when you combine those two, that really means your warming effect to the environment is going to be much worse than 100% combustion. That's why all the regulators are seeking a good combustion efficiency. There's a reason for that. If you don't, then that's like a problem, right? So that's really the background. Bear in mind, this one I'm going to skip. So I'm going to quickly go through some of the regulation history. So, I mean, there's an expert in the room, feel free to chime in. So historically, basically, you can look at the farm and say, hey, look, there's two general regulation. One is no black smoke is allowed, right? That's regulation one. So for operators, whether it's Chevron, Valero, when you got to think about this farm, so hey, in order to put out the black smoke, I'm going to inject steam. So I would rather be safe than sorry than I'm going to inject a bit more, right? So by doing that, and you dilute the energy content inside your combustion zone. So the end result could be you reduce your combustion efficiency. EPA recognize that problem. So Holterman. So you guys put a lot of speed. True, there's no black smoke. But on the other hand, I need to make sure you have enough energy content in the combustion zone. That's where we start to have the RSR map rule. You say, hey, not only the other things that I talk about, I also want to make sure you have good energy content in the combustion zone. That's why we regulate that. So the regulation is on the page. I mean, you can read it yourself. I'm sure you guys are all familiar with that. So it really tells you flare must maintain a minimum combustion zone net heating value, Q7, right? So that's the history. This is the full refinery. As you all know, EMAC is also coming to the petrochemical sector. So by 2023, that's need to be implemented there as well. So refinery first, petrochemical next. So the regulation is very, very similar there. So that's exactly the journey of our thought process, how we are developing. How can we develop more than a meter, become part of the solution? That's where FlareIQ comes from. So there's a 3 messages I want to deliver for FlareIQ. So if there's anything you want to remember about FlareIQ, FlareIQ is a platform. And the way you think about a FlareIQ is your phone, whether it's an iPhone or Android, doesn't matter, right? It's your phone. And then, given that platform, we build different apps on top of that. There are 3 apps I'm going to introduce today. One, emissions control, which I'm going to talk about, right? The second one is called digital verification, and which Victor will go through details as well. Then the third one will be monitor combustion efficiency. Those are 3 things. And that's my whole main focus there. So then you said, hey, why Panametrics has something secret sauce to offer in this case? I'll start with the emission control, which is here. The deal is this. As I mentioned earlier, Panametrics is specialized in flare meter. So we do flare metering for the last 40, 50 years, starting in 1980, and that's 40 plus years already. So we know quite well how flare is operating at different refinery petrochemical. We can output a velocity, volumetric flow, mass flow. So in order to get mass flow, you need to measure the density. How do you measure density? It's not a rocket science. So ultrasound is based on the philosophy of the sound. Sound travels at a different speed in different medium. For example, I'm talking to Russell in this room. That's really 340 meters per second, roughly in air, room temperature. Give it a take. And if I'm talking to you in hydrogen, H2, and that sound speed is much faster. So if I can measure, I have one sensor. It's just like ultrasound is like I'm talking, exactly I'm talking. I'm time myself, I time here. Russell takes so long before you can hear me. So I know how fast sound is traveling. By knowing how fast sound is traveling in this medium, I can know roughly the molecular weight. So in air, 28 molecular weight. Hydrogen, 2. So I can know the molecular weight. Knowing the molecular weight is related to the density of the gas. So we can measure the mass flow. Why I'm saying that? This is really our secret sauce. When you think about, hey, why is Panametrics doing flare control? Is because we know molecular weight. Molecular weight, if you think about it, is also related to the energy content of a specific gas. So if I know it's hydrogen, I can know the BTU value of the current gas. If I know this is methane, I also know the BTU value of the methane. So knowing those, it really offers a lot of intelligence besides the flow measurement. That's how we leverage that for our control solutions. So Mike briefly talk about it.
Yes, low.
Okay,
Yes.
Mike briefly talk about it here. If you think about that, right? whether you petrochemical refinery, this is how it works there. So, but in order to measure, you need to have some kind of feedback. Any control need a feedback loop. So if, hey, your end goal is I want to make sure the combustion zone has a BTU value of 270 per scuff. Then how do you know? How do you know you need to give more gas or fuel gas or more steam? So the way to know that is we utilize our molecular weight and we derive the BTU value and using that as a feedback for our control algorithm. It's much easier for me to say than done for sure, right? There's a lot of algorithm IP behind it, but in a nutshell, that's what it is, right? So that's why we say, hey, Mr. Customer, if you install our FlareIQ into your DCS, we are not controlling any of your valve to fuel gas or flare gas or steam. What we are going to do is, I'm your advisor, I'm your partner. I'm going to tell you at every moment how much steam you are going to need, how much fuel you are going to need in order to do two things. One, compliant. What's the compliant? So RSR called out the rules. I need to make sure I'm compliant. Secondly, I want to make sure you are very, very efficient to reduce your operational costs. There's many ways to be compliant. I can give a lot of fuel to make sure it's burn hot all the time, but you are wasting a lot of fuel. There's many ways you can achieve the compliant goal, but we believe there's an optimized way to do that, to minimize your operational costs, right? We believe this is what we offer to the table. And also for operators like Chevron, Exxon, we are not controlling any of your stuff. You are doing that through your DCS. And we give you the set point for everything. And that's like a real time. It's not a 5 to 10 minutes delay. It's like every second, every couple of seconds, give you the set point for everything you do. So that's really the flare control piece of that. So any details you want to know, and feel free to talk afterwards, right? The second piece I want to talk about, hey, FlareIQ is your iPhone. We build an app for control. Then how about the second piece? What else can you do with that iPhone? There's a lot of things we can do. So Exxon, Valero, you buy our ultrasonic meter. Historically, you need to make sure your meter is working properly. So every once in a while, you need to go and figure out. There's vendors might be telling you, well, you don't need to do any of that. So that's a dangerous statement. The analogy is like this: for your annual physical check. I mean, that's how healthy you are. Do you really want to skip that every year? That's your personal choice. When it comes to your critical asset, which is our flare meter installed in your facility, how often do you want to do that? So historically, we normally go there. You check the meter on site. Sometimes you even need to build a scaffold and to make sure you go and access to those meters. So using the same analogy, leveraging the FlareIQ platform, now we don't need to do that anymore. What you need to do is almost, hey, late. And I need to monitor your heart rate, blood pressure, all the other things there. On the other hand, I collect all that information. There's a pass-fail criteria on this FlareIQ box. Like there's an app. So for my height, for my age, it's supposed to be 150 pounds is the perfect weight, for example. If I'm 200 pounds already, it will tell you, hey, mister, got a problem. The same analogy for our meter. So I think basically it's a, hey, I show one example, go all the way down. I show one example how it works there.
More?
Yeah, more, all the way more. So yeah. Yeah, this is the digital, right? So I think this one might cover it. So yeah, go ahead. Next one. So example. So basically, this is what you are going to see out of our app. So which means we know our meter. So for example, if I'm the transducer installed in your pipe. If the background noise is very loud, or my voice is getting weaker. So by knowing that, say, hey, too much noise, you can make a very reasonable measurement And this will tell you. So it will tell you whether you pass, you fail. I mean, in the future, which is not available yet, we want to make sure we can do more proactive, like predictive maintenance. So, hey, Mr. Customer, in 2 months, your transducer might need some maintenance there because your signal is really decreasing. So, but for now, what we can do is offer a digital verification so that hey, I don't need to see a doctor. Those information will be sent to the doctor. Doctor evaluate me, say, hey, you're good, or there's something you need to do. So, okay, go ahead.
Existing Panametrics controller doesn't it have this feature built in that is some kind of fault diagnostics?
No, but I think existing meter offers all those diagnostics parameters. For example, signal strength, those parameters are available. There's no intelligence algorithm to tell you they are good, bad, or other. So that's where the app is coming in to do that. Right? Okay, yeah, good question. Right. And I think that's the digital verification. And can you go back to the combustion efficiency? So the last feature, I said 3 features. I talked about flare control. I talked about digital verification. Last one I'll talk about it. Hey, and Russell, you know, for upstream, there's no air assist or steam assist. So what can FlareIQ bring to the table, right? What can we do? So today there's an industry gap. I don't pretend we have a solution. I don't pretend we have a perfect answer, but I think this is the first step at it. So when you think about upstream flares, wellhead, for example, you basically burn whatever comes down the line. There's no air assist or steam assist. So then the real question is, how do you know how efficient you are burning those waste gas come to the flare pit? The answer is we don't know. As an industry, we don't know. So well, then you say, well, certain flare pit manufacturer is telling me what kind of efficient I'm having. And that's called the emission factor you might be using, but that's not real time. It's more theoretical value, probably preset 98% in general. And not a real time, it's a fixed value. So imagine how can we be so sure about our emission if we don't even know the combustion efficiency? This is the type of problem to solve, right? So I think, I mean, of course, Russell, you say, well, the most critical thing is to make sure you have pilot flame that's running all the time, branding, right? That's the first step. You need to make sure it's burning all the time. Then we talk about, hey, how efficient you are burning. So at Earth, think of this way. I mentioned earlier, we are flare meter provider. If I know what kind of molecular weight, if I know the weather condition, the weather, wind, how much wind you have, right? And the temperature, those things. And if I know that, I know what kind of BTU at your combustion zone. If I know what kind of BTU in the combustion zone, I can derive the combustion efficiency out of it. Well, the reason was, well, you can't be so sure. But think about this. EPA did the same thing. Ask the BTU value in the combustion zone, 270. Why they are asking 270? Because they fundamentally believe when you have a 270 BTU per scup or higher, that's leading to a 96.5 combustion efficiency or 98% destruction efficiency. They did that experiment for everybody else. So by the same logic, we flip the equation. If we know the BTU value, we know the weather condition, we have a very good way to derive your combustion efficiency. And that combustion efficiency is real time. I give you a rating of combustion efficiency every second. So can you go to the chart on the efficiency? So I think, so we develop that, we implement that in our FlareIQ. So we also go to one of the European operators, and we partner together to see, hey, what kind of comparison you can have out of it. So what we did there is, in this case, they have FPSO, and so basically offshore flare. And we use our FlareIQ algorithm to give their combustion efficiency. Not here, so because the chart of forward towards the end. Yeah, that's right. Stay right here. So this is the experiment we did, right? I think so. I'll explain to you. So for offshore flare, you typically see like the picture on the far right. And normally you have a low pressure flare, high pressure flare. That's very typical. And so that's you have a tube. So what you are looking at there, the green line is the combustion efficiency we measured through FlareIQ for the low pressure flare. And the red one is for the high pressure flare. So then you must be asking, what's your golden reference, right? As some gentlemen discussed yesterday, there's no golden standard to measure combustion efficiency at this very moment. There's a couple of things available besides FlareIQ. The other one is the camera. So basically, you use infrared camera to take a picture of the flame at the top. So basically, you use infrared, then you can use the absorption spectrum of that infrared picture to derive the carbon dioxide and other hydrocarbon that's not burned. So based on that, you derive back what kind of a combustion efficiency. Think about it. Your hydrocarbon come in, it will be burned, becoming carbon dioxide and left over. So by taking an infrared camera image, I derive what's the leftover, what's the carbon dioxide. Then I back calculate what kind of a combustion efficiency I have, right? So we compare our result with theirs. That's what you are seeing in this picture. The green, red is ours. Then the dotted, all those is the camera. It's scattered quite a bit there. Let me explain what's some of the observations we have. Number one, and apparently our technology is real-time continuous. That's why you see a continuous line. That's one observation. The camera technology is basically sampling, right? So once in a while, sometime there. That's one observation. The second observation is that our measured combustion efficiency is higher than their measure. It's also a little bit higher than the emission factor, 98%. So for those, and what does that mean? So we said, well, the scale is a 99.5 all the way to 95. That's not a big deal. It's only 5%. Think of it this way. Any methane you did not burn will go up there. So 1% makes a huge difference. In terms of your carbon tax, in terms of your emission reporting, that's a big deal. That's really a big deal. So even 0.5% difference makes a huge difference, right? So that's just put everything in perspective. That's one. The other one is you also see, well, your technology is showing a much more stable reading versus the alternative is very much scattered. Which one is telling the truth? Well, the honest answer is that we are not so sure yet. So what we can tell you is this. Think about that. For those upstream flares, why the combustion efficiency from the other technology is scattered so much? Why the content is relatively stable? That's an alarming sign to begin with. It turns out that the alternative technology is sensitive to a few things. And that's wind. If you have a high wind versus low wind, the reading can be changing quite a bit. And also sensitive to black smoke. If you have more black smoke, imagine this is taking a picture, right? And also because you take a picture, those two high pressure, low pressure flare tip is within one picture frame. You can't tell difference between LP and high pressure. That's why you only have one output there. So our measurement is very, very promising. It's in line with the alternative technology telling you, but it's quick time. It's higher than emission factor, and it's also much stabler. So there's more work we are doing by working with different operators to get this one optimized. Eventually, we think this could be the standard or a good way to measure combustion efficiency for upstream flare. All right. As a recap, I talked about three things based on FlareIQ. FlareIQ is not one thing. You think about FlareIQ, you think about an iPhone. There are 3 apps we build upon that. One, to do assisted flare control. We call it emissions control solution. The second one, we can do digital verification. Think about the remote annual check for lay or wherever. The third one is we can measure combustion efficiency for upstream flares where there's not much assist. So that being said, I pretty much that's what I have. Any questions, comments?
I have a question. How far into your process you get, maybe you haven't experienced it yet, before you find out you're dealing with an antiquated flare or an improperly designed flare? Like you build your app, like in your example, and you have an iPhone too.
Yeah. I just want to make sure I understand your question. So
You're talking all measurement
Yeah.
and metering of steam, but if flare itself is improperly designed and it can't handle maybe the volume, it's just, it looks good at 90%, and you're like, well, I'm going to make it 98, and you find out I can't get it to 98 because it's from 1950 and it's not a good flare.
yeah, so that could be very true because so far we only did one major comparison here, right? There's so many different flare tips out there. So I think I don't mind speaking of this. One of the optimization solution we are thinking of is we are going to build the flare tip design into our model to refine it. So if you have flare tip built in the 1950s, so your design probably is not optimized there. Your combustion efficiency could be low there, right? That's in the process for now. And hopefully next year when I come over, we have more results to share with you. Right? Good questions there. Go ahead.
So what do you think about enclosed combustion devices? The thermal oxidizer. Like you talk about combustion efficiency. So we're ISO certified to 99.99% combustion efficiency.
Yeah, I think honestly, for me to comment on alternative technology is a little bit hard, right? So I think why don't I spin the question the other way? What's your thought on that?
Well, we're ISO certified, but what I was telling Mike earlier is my customer, they believe me that I'm ISO certified and we can explain it, but they want to see something from like the FlareIQ that they can get a show on a piece of paper to give to the regulator that yes, I'm actually doing it. And so we can't say, give the species coming out, but we can absolutely prove and we have the certification. So I think a marriage of both technologies is the answer because you talk about variances. Flare, you can combine it in the stack and control the residency time. You can do that. So I think it's a good partnership with technologies.
I do agree. I mean, this is a challenging problem. I don't think the solution resides on one thing.
Yeah.
It could be a combination of the few things there.
For sure.
So I think we'll be happy to partner together. I mean, if the case is right?
For sure.
Yeah.
Yeah. That's great.
Good comment.
Good stuff.
In this tool or collection of tools that you have, including the logic calculation, camera that you use, I'm assuming the calculated combustion efficiency that you have, using the camera, and say you look at how much is the predicted combustion efficiency or is purely beyond
I think the camera, by the way, just clarify, we don't own the camera technology ourselves. So I think that's just an alternative technology. We work with the operator to as a reference. Right? So like, hey, you measure this way, and at the same time you measure it through a different way, so you can compare the results. So we don't own that, but
so FlareIQ does not use a camera by itself.
no, FlareIQ by itself is not.
This is a validation of.
Yeah, this is really a way to give us some confidence, right? And plus, camera technology is also not exactly blessed as the golden standard. So we are trying to solve this problem and use a collective, right? Yeah. Good thought. Yeah.
And this is, you said, unassisted.
This one is unassisted. Upstream typically is not exactly assisted.
But the benefit of this technology will be validated or acceptable.
Yeah, I think that the same technology will work for downstream refinery and petrochemical. The thing is, from a regulator perspective, TCEQ, you guys comment on this, right? There's no EPA asking, hey, give me your downstream combustion efficiency. Basically, they say, I set the bar for you. You either above the threshold or you below. That threshold is controlled by the 270 BTU per scale. That will lead to a reasonable combustion efficiency. Anything higher than 98% or 96.5, depending on the definition, they don't care at this point. In the future, they might need to refine that number, right?
And that's what I was going through is that if this tool tells me that on your design on the operating condition, you are expected to get 98% plus.
Yeah.
But the tool tells me I'm 99.5.
Yeah.
Really?
Yeah, no, that's a very good point. I think, yeah, maybe Exxon and we should together make a case to EPA, right?
And that's I'm sure.
Yeah, I'm using you guys as an example. I think that's a very valid point. I wish there's people from EPA sitting in this room. Last couple of years, we've seen them here. So I think, and as a supplier, it's hard for us to try to, hey, oversell our technology, but that's really the benefits of that, right?
But one question that raises, if you do not have a camera, something looking at whether it's about to smoke or smoking.
Yeah.
I mean, typically the flare controls steam or air assisted, how much is the BTU coming in and what's the ratio of the hydrocarbon and steam. I mean, 2 kilotons an hour of steam, right?
Yeah.
And this tool can actually fine tune that you don't need 2 kilotons,
Yeah.
1.2,
Yeah.
700 miles an hour. When you do that tuning, how do you make sure? Because flare, as you say, all cats and dogs, it's a sewer system, right?
Yeah.
So how do you make sure that it will not smoke? How do you come to that?
Yeah, so I mean, I'm assuming you are referencing the downstream flare because for upstream flare,
Yeah, you're right.
yeah, whatever comes down the line, I burn it. So whether, I mean, I don't have any leverage I can pull, right? Lever I can pull to control it. For downstream, you say, hey, how do we leverage the black smoke? Here's the deal. So the lever you pull for black smoke is pretty much steam or air. I mean, steam will do a couple things for flare. One, I mean, when you eject the steam, there are 3 things normally you need steam for. One, flare tip manufacturer, Zinc or Zico, you ask the minimum steam to pull off the flare tip. Mike mentioned earlier, right? That's a small amount. The second one, when you eject steam, it really increase the circulation of air. The air is oxygen. So when you increase the oxygen, you foster a stronger combustion. So then the real question is, how do you know when you need steam and by how much, right? So the trick is to come back to the molecular weight. So in our case, if you are burning hydrogen, which is probably the cleanest fuel you can get, and it doesn't smoke, I mean, in general. So in other words, when you have molecular weight of 2, which is hydrogen, and other than the minimum steam you need for cooling off the flare tip, you pretty much don't need to inject steam beyond that. On the other hand, if you have a high C, C5, C6, I mean, all the way C10, it tends to smoke easier. But our unique algorithm is we know those things. We can tailor the steam based on gas composition. I say that at a higher level, but there's a lot of details algorithm behind that, right? But at a higher level, I can tailor that to ensure you have no black smoke, but minimize the steam consumption, because it's very easy for operator to inject more, not less, right? Does that answer your question?
Pretty much in real time.
Yeah, exactly.
To some extent, nitrogen is 28 molecular weight. I think it's
Yeah, that's a really
so I'm kind of going into.
No, very good question. That's I mean, for me, I'm an engineer. I don't sugarcoat. That's a challenge. However, there's a solution to go around that. For example, and if you in our meter, for example, or FlareIQ, and where the nitrogen come from? In general, there's a couple of things there. You know, you sweet gas, purge gas, or there's something left over from the air. But if using your GC mass spec or other means, you know roughly how much it is. In our flare meter and FlareIQ, you can consider that. So you either a live input or a fixed month if you know. So for a lot of the operator, for example, I have a pressure gas line. If I can measure how much nitrogen is coming through that line, I can enter that value to our meter. So that problem you just mentioned is compensated for that. So which means I already take into account how much nitrogen coming in. So my algorithm can be more accurate. Without that, your algorithm is less accurate. Right? That's like one solution. There are others. Yeah.
I think the other part of that, I think something is that if you're having a large nitrogen release, through to the vent, the control room will know that you're voiding a tank and you're putting like a good portion of nitrogen through. And so I think there's a temporary number in there as well, just to, it doesn't have to be a static for the entire facility.
That's lunchtime.
There's ways to compensate for it.
And I'll just say this, but for ours, knockout for liquids to go through, there's usually a knockout drum, but sometimes if liquid will get in, it'll generate black smoke just for a second. So I know this is different, but a knockout drum
Yeah.
will knock out water.
Yeah. Okay. Yeah, that's a good point. Yeah.
Yeah, and I think what you're talking about is that to come into the conversation about others would be, but on the nitrogen, yeah, I mean, you can definitely compensate it. I don't really have usually tell you in seconds, at the same time, what I'm more thinking about, you have a something that people or less people, and they have their own inherent behaviors. They're not exactly the same. That you need 0.7 and you need 0.5. Even something to have.
Yeah, exactly.
How to find you, I see that's probably more of an art. And that was the approach.
Yeah, no, I think probably there's work in the process that we are doing now. I can't share a bit more because there's a IP related there. So I think we are thinking of directionally. I can tell you this. Directionally, we are thinking of factor the design of the Vtip in each our model. There's a couple ways you can do that. I mean, CFD is one of those, right? For example, and make it more accurate without releasing more details. So you see the direction we are trying to think of.
Yeah. We will definitely talk about.
Yeah.
Any place that's going to be strong, FlareIQ.
Oh, so I think go to the last slide, Victor, if you don't mind. As I said, FlareIQ is 3 generations already. That's only within a very short period of time. It's like since 2017. So we have 50 installed, operating, and 10 being piloted there. When I say 10, for example, one major operator, they might have many. We just tried the first one. That's 10 in the pipeline. There's many others in the pipeline there. So it's certainly not new, but I think 4 years of the journey we have gone through, and it's quite promising there. I mean, of course, we'd like to work with Exxon, right? On some of that. I mean, there's nothing to lose, in my view, to try that, right? So I think whether on the first generation, second generation, or third generation, depending on what you have there. Right? So
we actually
hey, our commercial guys are always in the room.
Thomas is adding multiplier too.
We can always work something out, but I think that the point of this is that we're not on serial number 1. I remember serial number 1. There was a challenge as we, just in the robustness of the algorithm and getting it so that it can handle, the needs of a refinery. Let's face it, it's not in a lab. There's a big change there. And so the flare control aspect has been proven and embedded fairly well, operating. The digital verification, which Victor's going to talk about, is something that I know Exxon has been looking at.
Yeah, Exxon Beaumont Chemical has it, and then we're working with both of the Baton Rouge sites. I think this in the next coming weeks they'll be signing with that.
So it is something that's almost all of the major refiners in the U.S. have at least one site on it.
All right. So Victor, how am I doing on time?
6 minutes over. That's all good.
Yeah, thanks.